Hi students, welcome back to your physics class. So in the last session, we have started our conservation laws. So in that, we have discussed regarding the statement of law of conservation of linear momentum, how it conserves in case of single particles or the system consisting of n number of particles. Okay. So the statement of your law of conservation of linear momentum is in the absence of any external force, the total linear momentum of all the particles in that system remains constant. Okay. So how that linear momentum remains constant? So that is, I have told it with an examples in single particles or the system consisting of two particles or any n number of particles. So today, so in this session, so we will discuss about what is the distinction between your laboratory frame of reference and center of mass frame of reference, and as well as a concept of elastic and inelastic collisions. So here, so before dealing that your laboratory frame of reference and center of mass frame of reference, so first you should know what is the meaning of your frames of reference. So whenever we want to study the motion of the object, we study the relative motion of the object with respect to some arbitrary chosen object. So here, the absolute motion is a meaningless concept. The absolute motion is a meaningless concept, while the motion relative to some other object is having a certain significance, is having a significance. Okay. So for that purpose, so what to do is, so fix the position of moving object related to the chosen object of references. So you want to what? Fix the position of your moving object with respect to some reference point. Okay. So here, this red spot is the one, what it is. Some event is taking place at this place. So let us fix the position of moving object with respect to the this reference point or what this reference point is. So for that purpose, it is convenient to have the coordinates and you make the coordinate system for this. It is convenient to have the coordinate system fixed to the so reference pointers or reference objectives. Okay. Such coordinate systems, you have to specify the coordinate system for the motion of these particles. Specify the what? The coordinate system. So those coordinate systems will describe the nature of that particles. What it is convenient to have the coordinate system fixed to the reference object. Such coordinate systems are called as frames of references. The system of coordinates in space. So here the something is going on here. So in order to describe the events which is taking place in this place, so you have to fix the coordinate system. The system of coordinates in space which defines the what? The position of the object or the particles. So whatever the coordinates you are fixing for this object inside this space, so those coordinates will give you the what? What is the exact position of that particle or what? Object. So that is called as what? Frames of references. What it is? a system of coordinates in space which defines the position of object or particles is called as frames of reference. So whatever the coordinates you are fixing for that object, so those coordinates will give you the complete information regarding that objects. Okay, so they are nothing but what frames of reference. That is a fixed point. Okay. So here, so we know that we are having three types of coordinate system. One is Cartesian coordinate system. The second one is cylindrical coordinate system. The third one is the spherical coordinate system. So one of the simplest and best coordinate system is a Cartesian coordinate system. That is your x, y, and z system. Okay. Another thing is there are two types of frames of reference. One is an inertial frame of reference. The second one is a non-inertial frame of reference. So what do you mean by an inertial frame of reference? An inertial frame of reference is one in which the Newton's laws of motions are what valid or holds good. Such frame of reference are called as inertial. There is nothing but a laboratory frame of reference. Inertial frame of reference. In such frame of reference, an object at rest remains at rest. An object in motion continues to move at constant velocity since no force acts on it. Such frames of reference are called as what is inertial frame. They are also called it as what? A laboratory frame of reference. In simple words, the laboratory frames are the one in which the position and velocities are measured with respect to the laboratory frame, with respect to the certain fixed area. The fixed area is what is laboratory frame. So here, O1 is the person who is situated in the point at this point at the center of your these three things. O1 is the what? The person who is located in the system of coordinates, first coordinate system, and here he is measuring what is the position and what a velocity or any acceleration of these particles. So with respect to this reference point, so this x1, y1, z1 is a coordinate system, and O is the what? The fixed point. So from which he is what? The measuring all the variables. So similarly, and x2, y2, and z2 is the what? The another coordinate system. So here O2 is the person who is situated at this point, the person, and he is observing the same event which is taking place at these positions. So he is also measuring what? So what is the position and what? And velocity and acceleration of this object. So such frames, so we are naming it as, we are calling it as what? Laboratory frame of references. Okay. Next, and what is your non-inertial frame of references? A non-inertial frame of reference is one in which Newton's laws of motions are not holds good, are not valid. So such frames, we are calling it as a non-inertial frame of references. So the example for your non-inertial frame of reference are so all the accelerated frames of reference are an example for your what? Non-inertial frame of references. Okay. So I think you know the meaning of a laboratory frame of reference. So laboratory frame of reference is the one in which whatever the variables, velocity, acceleration, and positions are there, all are measured with respect to what? One fixed point. That's nothing but what? One reference, one frame. That is the laboratory frame. Such frames we are calling it as what? Laboratory frame of references. So laboratory frame of reference is nothing but an inertial frame of references. Okay. Next, the center of mass frame of references. So another frame of here. So in this case, they have used the word center of mass frame of references. So in my last class, so I already have defined what is your center of mass. So whenever the system consisting of a what? N number of particles. In such cases, it is difficult to specify the position of individual particle in that system. So for that purpose, so what we are doing is we are considering one point. So that point is what? Where that the entire mass is what concentrated at that point. So that point we are calling it what? A center of mass. The point at which the whole mass or the what? The entire mass is concentrated uh, at that point of a system of particles is called as center of mass. And here the center of mass frame of reference. That means the center of mass of the system is to be taken as a what? A frames of references. So see here. I'm having particles of M1, M2, and M3, up to what? Mn number of the particles are what? Existing inside a system. And the IJKL is the what? Your Cartesian coordinate system. So with respect to this reference point, with respect to this chosen object, so we are measuring all the variables. So what is the position of this particle with respect to this your reference point? So R1 is what? The distance of your particles M1 with respect to chosen pointers, fixed pointers. Or you can call this R1 is nothing but what? The positional vector of this your mass M1 is. So similarly, for the particle M2 is what it is R2. This is the distance of your M2 from what? A fixed point. And M4 and M5 and like that. So we are having what? N number of particles are existing. So inside that our isolated system where Rn is the distance of what? N particles from this reference point or the what? The fixed point. Okay. So in this system, it is difficult to specify the motion of what? These individual particles. So for this purpose, we are considering what? One point inside that system. So where that entire mass is what? A concentrated. So that points we are naming it as what? Center of mass of that system. Okay. So here, this center of mass of this system is taken as what? The frames of references. The center of mass of frames of frame of reference. The center of mass is taken as what? The frame of reference for that system. Okay. So here, the center, if the inertial frame of reference. So here that Ijk is my what? Inertial frame of reference. If it is fixed with what? Our center of mass of an isolated system, the word is inertial Ijk is the inertial frame which is fixed with your what? Center of mass of an isolated system. Then the center of mass is at what? Rest. Whatever this center of mass is, when it is, the inertial frame is fixed with your center of mass of our isolated system, then this center of mass is what? Is at rest. Is at what? Rest with respect to your what? Your inertial frame of reference. Then when you are saying that the center of mass is at rest with respect to inertial frame, then VCM, that velocity of center of mass equals to 0, then automatically you are getting what? PCM means that momentum of that system equals to 0. So such frames of reference, so is called as what? Mass, center of mass, a frame of references. So what it is? So this one I have considered what? One of the isolated systems. So in that we are having what? N number of particles. So all these particles are what measured with respect to the point, to this middle point, center point. So R1, R2 and R3 and Rn are what? The distance of these particles with respect to the our chosen object or reference point, or you can call this as what? Fixed points. Okay. So here, so it is difficult to specify the motion of these individual particles. So for that purpose, so in this case, we are considering one point. So that point is nothing but what? A center of mass, where the entire mass of that isolated system is what? Concentrated. So that point we are naming it as what? Center of mass. So here, this center of mass is fixed, means that inertial frame of reference Ijk is our what? Inertial frame of reference. This is what? Fixed with the center of mass. Mass of an what? Isolated system. So then this center of mass is at what rest. When this inertial frame is fixed with the center of mass of an asteroid system, then center of mass is what fixed, is what is at rest with respect to this your inertial frame of reference, and so that your VCM equals to 0, then PC, automatically your PCM becomes what? The momentum of that system, center of mass of the system equals to 0. So this frame of reference is called as what is center of mass frames of the references. Okay, this is so simple. Next, after that, another concept in this chapters we will discuss about what are collision processes. What it is? Collision process. So we know that the collisions are of what two types. A collision is said to be takes place. A collision what? Is said to be takes place when two particles interact with each other and undergo and what? Whenever those two particles get to interact each other, so what is happening? There is a change in kinetic energy as well as what? The momentum of those two particles. Okay. So here we are having two types of collision process. One is elastic collisions and another one is what? Inelastic collisions. Okay. So let's see here what is elastic collisions. What is the definition of your elastic collisions? The collision process is said to be elastic if the total kinetic energy, what it is? If the total kinetic energy of all the particles before collisions is equals to what? After collisions. Or you simply call it as a collision process is said to be elastic if the total kinetic energy is conserved. If the what? The total kinetic energy conserved, then uh, your collision process is said to be what? Elastic collision. Whenever the kinetic energy of the system is conserved, then the collision is said to be elastic. So in this case, that total momentum, the linear momentum of that system is conserved. Kinetic energy is also conserved. The exact definition of elastic collision is if the kinetic energy is conserved, then the collision is said to be what? Elastic collision. That means the collision between two particles before collision is equals to what? After collision. Suppose M1 and M2 are the what? The masses of two particles, so which are having their initial velocity V1 and what? U2, and V1 and V2 are the what? The final velocity of those two particles. So therefore, so according to statement, so it is given what? 1 by 2 M1 U1 plus 1 by 2 M2 U2 is equals to 1 by 2 M1 V1 squared plus of what? 1 by 2 M2 V2 squared. So similarly, that total momentum is also conserved in case of what? Elastic collision. That is a M1 U1. The total momentum before collision is equals to what? The total momentum after collision is. So M1 U1 plus M2 U2 is equals to M1 V1 plus of what? M2 V2 is. Okay. So the examples for your elastic collisions are what? The collision between atoms and molecules. The collision between what? Atoms and molecules. And as well as the collision between your what? Two microparticles and as well as what? A nucleus. Microparticles and what? Nucleus. So in case of elastic collisions, whenever those two particles collides with each other, there is no change in the internal structure of that atom. That remains as is. That's the things happening inside your what? Elastic collision is. Okay. Next, let's come to another collision process. So which is nothing but what? Inelastic collision is. A collision process is said to be inelastic if the total kinetic energy is not conserved. Means the total kinetic energy of those two particles before collisions, the total kinetic energy of what? Those two particles before collision is not equal to what? The total kinetic energy of those two particles after collisions. So that's why. So while defining inelastic collision, If the kinetic energy is not conserved, then the collision process is said to be what? Inelastic or collisions. But here also, the total momentum, the linear momentum of the those two particles remains constant, conserves. Okay. So here, the forces involved are non-conservative, but there in your elastic collision, they are what a conservative processes. Okay. The example for your inelastic collisions are the collision between two bigger objects such as cycle or car, truck or what, car, or a bullet hitting a target. So whatever the collision process that takes place in nature are all the what examples for our inelastic collisions. So in this case, when two objects collides with each other, there is a loss of some initial kinetic, some initial energy. That loss of energy is in the form of what it is, sound or what, or you can say it is what activities. Okay, so this is about your what inelastic collision. That's why whatever the loss of initial kinetic energy is in the form, it may be in the form of what? Heat or sound. That's why the total kinetic energy before collision is not equal to what? The total kinetic energy after collision is. Okay. So this is about so the distinction between your what? The laboratory frame of reference. So as well as what? The center of mass of frame of reference. And next, what is your elastic and inelastic collisions? Okay. Thank you.